Hi, welcome everyone to the Cesium BOF. Thank you for joining us this morning. My name is Patrick Cozy. I started the Cesium project back in 2011, and we've been having the Cesium BOF here at SIGGRAPH every year since 2013. This is our very first year that it's being live streamed, so kind of moving up in the world. I feel that's very cool. Has anyone been at a Cesium BOF before? Awesome. So we got about a third. And then how many people have heard of Cesium before? Most. Oh, this is cool. All right, very, very cool. So today we have 5 presenters on a variety of topics, both on the world of core Cesium as well as some really great community use cases going on. So Gabby from the core Cesium team will give us an overview of what's new and what's to come. And if you were here at the Cardo BOF yesterday, she'll go in a little bit more detail than what you would have saw at the Cardo BOF. And then the Mozilla folks have been using some Cesium data in A-Frame for some mixed reality experiences. Anselm unfortunately could not make it. He is on the live stream right now, though, so Shazan from the Cesium team will present in his place. And then Tam from ESRI, this is his second year presenting in the Cesium BOF. We'll talk about some I3S and potential interoperability between ESRI and Cesium. And then Dimitri from Safe Software will talk about some more data interoperability between the FME and Cesium. And then we'll round it out with one of my favorite topics right now, which is autonomous driving simulation. And Vangelis from Toyota Research will talk about some of the work that Toyota Research is doing with Cesium. And then for folks on the live stream, if you have any questions, if you tweet them at CesiumJS, we'll figure out, we'll get to them, and we'll try to answer those as well. And then we'll post the slides, and all the presenters that are able to post our slides, we'll post them on the Cesium blog and on the Twitter as well. So with that said, Gabby, it's all yours.
Thanks, Patrick. All right, so so we're going to take a look at some of the latest and greatest from core Cesium. I'm Gabby. I'm a software developer on the Cesium team. I've done a lot of work with core Cesium recently, 3D tiles and GLTF, and I also work with the community on like the forum and things like that. So you all know Cesium. It's our open source WebGL library for rendering 3D globes and maps in the browser. But lately we've been placing a lot of emphasis on data fusion. Data fusion is taking data from a whole bunch of different sources and viewing it all in one viewer. And you really get a picture for how the data intersects, it overlaps, and interacts with each other. So as a demo of this, this is not a photograph. This is a point cloud. So let's take a look at that video. So we've been working on data working with data from a company called Trimble, and they capture point cloud data. This is a 6.4 billion point data set collected from 72 scan locations, and it's of historical cabins in Pharsalia, Virginia. It's fused with terrain and imagery, and it uses techniques like point size attenuation and eye-dome lighting for these really nice views in Cesium. So one of the first things that is new in Cesium is materials on polygons on terrain, which is basically what we're doing is computing terrain position for each fragment in the decal. That's what the material is, using the window coordinates and the depth, the height of the terrain, and comparing that to a position in the bounding box and getting the UV coordinates. I would highly suggest taking a look at Gary's blog post on the topic, though, because he really gets into why GLSL's built-in inverse trigonometry doesn't really work the way you initially would think it would. We also have the long-awaited polylines on terrain, and it's fast, visually precise, and easy to use. It keeps an approximate screen space width, and it supports all of the existing polyline materials. It's got interactive performance with even thousands of polylines on mid-range software. As you can see, we're doing a lot with data on terrain, and this is in order to have terrain on by default. And one of these things that we really want to get to is improving, actually we've done it, I'm sorry, excuse me, is improved depth testing of billboards and labels on terrain. So previously what we did is you could have either no depth testing, in which case it would show through terrain like it is on the top left, or you would depth test against each fragment in the billboard, and that wouldn't get desirable results in all cases. So right now what we're doing is depth testing a few fragments, the top two corners and the bottom center, to determine if a billboard is visible or not, so we can get much better presentation like in the GIF on the right. Another feature, this one was actually an external contribution because Cesium is open source, which is pretty awesome. So we have custom materials that can be applied to the globe surface. And this is, you can create procedural terrain effects like what you see here. So you can show elevation, you can show slopes, you can show contour lines, you can show density of terrain, the sky's the limit. Another thing we've added support for is Draco, which is a library from Google that compresses 3D assets. You can apply it to GLTF models, 3D tiles, point clouds. And what we do is we decode in parallel using WebAssembly, and we also perform some of the dequantization on the GPU. So this leads to smaller file sizes and faster streaming. This is a comparison, and this is actually throttled, so you can really see the difference. And when you start to get back there and you're loading in all those tiles, you can really see how much faster it is. So Cesium has always had massive view distances, and we've solved this by using several frustums. You can see those several frustums on the right. So the nearer one would be the shortest, and it would give you the highest level of detail. And as you go further back, they'd be successively larger. So this is actually showing 3, but the first one's so tiny that you can't see it. But sometimes this would cause artifacts like you see in the foreground with z-fighting. And now we have implemented logarithmic depth, so you can have one much longer frustum, which leads to better performance because there are fewer draw calls, and it also gives you better visual quality, both removing artifacts, and the near plane can be moved closer without, in fact, impacting performance. Something else we've been working on is post-processing. So it's operations that can be performed on the view after the scene has been initially rendered. And you can do things like per feature post-processing here, like we're applying silhouettes to each feature in the tile set. And then you can also do some effects like lens flare. Lens flare is actually an artifact of physical cameras that we then emulate to make it look like real cameras. And ambient occlusion. So this is just the ambient occlusion view of a BIM tile set. We've also implemented clipping planes. So clipping planes allow you to hide certain part of your model, your tile set, your terrain, your point cloud. We perform this by just using transforms and discards in the shader, but we also have it integrated along with the 3D tiles traversal code so that if a part of your model is completely clipped, that won't be traversed. So it's optimized and you don't need to iterate through all those child tiles. There's also an infinite number of planes available, so you can create shapes like a nice smooth circle in the middle right there. Something else we've been working on is classification. So that allows you to selectively color or hide parts of a tile set and also go in and select those classification. This can apply to terrain, point clouds, photogrammetry, BIM, and the classification itself can also be a tile set. So in the GIF over there, the geometry is actually a vector tile set, or geometry tile set, excuse me, being applied to a photogrammetry tile set. And you can also hide certain parts of your model or only show certain parts of your model with it as well. So what's on the horizon? What can you look out for the next year or so with Cesium? So one thing is 3GS and Cesium integration. So 3GS, if you've heard of it, is a JavaScript rendering library. And we wanted to be able to combine content rendered from 3JS with content rendered in Cesium in the same context. And what we'd be doing is syncing the render loops to make sure they're being rendered at the same time and using the same coordinate system. So you can overlay geometry rendered in one on top of, say, terrain from Cesium. We've also been working on some atmosphere improvements, which you can see on the left, and also some high dynamic range and image-based lighting. Here's an example of HDR. So on the left, the night scene is a lot darker, and on the right, it's actually a little bit brighter. What high dynamic range allows for is values of the light to exceed 1, basically, so you can have much brighter values, and then it's scaled back down for rendering. And image-based lighting is the ability for us to render the content of the scene to a cube map and then use that cube map to perform lighting calculations on the object in the scene. We also have been working on some dynamic 3D tile styling. So you can see here some things like computational shading by angle, which was that first one. This is by angle, by distance. You can perform view sheds and really some real-time analysis on the GPU. So that's what I have for you today. Check out cesium.com and take a look around, try building something, and let us know what you build, because we'd love to see it and share it. And I also have a quick plug for all the other talks we're going to be at over the course of SIGGRAPH, so take a look. I'll take any questions if you have them.
First question.
Yes?
I didn't quite understand the image-based lighting. What's the connection between a cube map and lighting?
So you can...
Can you repeat the question?
Sorry. So what was the connection between image-based lighting and the cube map? So what you're doing is taking the luminance of the scene and creating a cube map based on that, and then you can use that to perform lighting calculations on the objects. So say you are in a, you can do things like take the luminance of the atmosphere, like the contribution of the entire sky, rather than just one light source. So it helps provide more realistic lighting for your model, basically. Yeah. Did that answer your question? Yes.
So the terrain and the binding of the terrain you're talking about at the beginning, that work for like custom tile sets as well, or is that only the Cesium world terrain?
The binding to terrain, can you clarify?
Yeah, like where you were showing the polygons being bound to this terrain all the time.
Oh, yeah, that'll work on any terrain. So that's done in real time, so yeah. Yes?
You're talking about the JS integration and changing your coordinate system and the render loops. How much of that is like kind of specific to integration with JS, or is that going to like change to the Cesium coordinate system?
So I think either Gary or Patrick might want to answer this, but I believe we're creating plugin points for more generic.
Yeah, so our intention here is to provide a plugin point into the Cesium rendering engine so that you could, it doesn't have to be 3JS, it could even be other WebGL engines, or it could just be raw WebGL. There's definitely going to need to be a little bit of work done both on the coordinate systems to translate from the coordinate system that engine is using to Cesium's coordinate system, as well as with the depth testing, because Cesium is using logarithmic depth and a hybrid with multiple frustrums. So we may have to end up like patching shader, like you write one shader, but then Cesium actually tweaks the depth value so that it can do the other one.
Any other questions? All right, thank you.
All right, thanks again, Gabby. Next up is Shazan, who's going in place of Anselm from Mozilla to talk about what Mozilla's been doing with A-Frame and A-Train and some Cesium data. Hopefully this works.
Hello, everyone. I'm Shazan. I'm a software developer on the Cesium team. As Patrick said, I'm here to talk on behalf of Anselm Hook and Mozilla, who've been doing a really good job with data fusion outside of Cesium. They've been using A-Frame to create geospatial environments in VR. So a little bit about A-Frame. A-Frame is an open source web framework for building virtual reality experiences. It's primarily a Mozilla and also maintained by the WebVR community. So A-Frame is targeted towards novices for building games and prototypes very quickly. You don't need to know the ins and outs of graphics and performance and how that affects over the web. So A-Frame also allows plugin components that can be used to extend A-Frame's inbuilt capability. This allows you to provide new experiences. So A-Terrain was one of these components that was created by Mozilla, and this was created in order to provide geospatial data into A-Frame. So A-Terrain can access terrain, imagery, 3D buildings, GLTF models, and put those in virtual geospatial environments in A-Frame. So here we can see an example of the terrain in Grand Canyon, a very localized part of it. So when Cesium can provide the entire globe and a whole lot more data fusion, the A-Frame component is more targeted towards doing smaller chunks and prototyping quickly. So this is an example from San Francisco. The buildings are from footprint and heights, and A-Frame can take those and put its own style on it. So it's not limited to the original styling that was there on the GLTF or on the terrain. Here's another view of the San Francisco skyline from the ground. So it's almost like looking in VR. I don't have a headset here, but this works straight up in VR as well. And pardon the pun, but A-Terrain component can also create out-of-the-world experiences. So you might be wondering what applications this might be useful for. So one of the apps that was created in Hubs was to have a collaborative trip planner. So you, your friends, your family, if you want to see where you want to go or what the environment might look like, this is something that it can be used for. Some notable features here, there's collision detection. So if you're, let's say, in San Francisco and there are buildings, there'll be collision detections inbuilt without any shader additions. It also works with VR out of the box, and it's easily scriptable in JavaScript, so pretty easy to get started on. And yes, it's open source, so you can go check it out. You can make your own A-Terrain if you want. We are very happy to work with anybody who's doing data fusion. And there's a blog with more details on how A-Terrain works.
Questions for Shazan? All right, thanks again, Shazan.
Thank you.
Tam, are you using your own machine? Tam is getting set up here, I'll just add, for the A-Frame work, we were using GLTF for the 3D building data, and then quantized mesh for the train data, and then I believe WMTS or TMS layout for the imagery. So it's a great interoperability story. Then Tam, getting set up here. Tam is from ESRI. He and I have collaborated over the past few years in the world of OGC, the Open Geospatial Consortium, where we've both been working on community standards for streaming massive data. I've been working on 3D tiles, and Tam has been working on I3S, and hence the title I see on your slides right here. So without further ado, Tam, it's all yours.
Thank you. Thanks, Patrick. So hello. As Patrick said, I work with ESRI. I primarily work with our 3D tiles format, our tile 3D format, I3S, yeah, many tile formats, right? But that's actually the essence of my topic here, is that there's a lot of synergy nowadays as far as, delivering data in very optimal, efficient means to web browsers, desktop application, and mobile systems. So what we do at ESRI is, as Patrick was mentioning, we standardized our index 3D scene layer as an OGC standard, and we are getting huge requests, users wanting to use I3S into our web-based application and desktop application, as well as 3D tiles in our application, and then also vice versa. Cesium users want to use I3S in their application and want to consume the rich set of datasets available in I3S format. So today I'll talk a little bit about our format, index 3D scene layers, and then some of the work that we have done with some organizations in trying to consume I3S in CesiumJS as well. So just a little bit of introduction about I3S. It's an open specification for storage and transmission of large amounts of heterogeneous 3D geospatial dataset. Cloud, web, and mobile friendly. If you were here yesterday at the Carto BOF, we demonstrated that you can consume I3S data in web application, desktop application, as well as mobile systems. Obviously, we support a lot of geospatial content, also with coordinate systems, with support for coordinate systems for different layer types. Last fall, right after actually SIGGRAPH, Patrick and myself, we've been all working and trying to get the different standards into the OGC system, and I3S was adopted right after SIGGRAPH last year as an OGC community standard. The fact that it was a community standard was a boon for us, because now data providers can actually implement this data format and be able to author and share content in I3S format for different applications. Currently, it's getting a widespread adoption in industry. Bentley, Vricon, Pix4D are some of the big ones that are outputting I3S content, as well as Safe here. I see them. They're here. They're also translating data from one format to I3S. So there is a good synergy right now going on, data providers churning out this data format, so the more reason to use it in different application. Quick overview of like the different layer types that are supported in I3S. 3D objects is the first, 3D objects and integrated mesh layers are the first layer types that we supported in I3S. And then earlier this year, around March, we released detailed specification for our point cloud solution as well. The idea being that once we release the specification to the open community, then the next versions of OGC will adapt the point cloud specification also. So we're going through that. So the first version of I3S, version 1.5, was adapted by OGC. Now I3S is already at 1.6, so hopefully in the next few months we'll be making that effort to get it into the OGC standard. As well as points with symbolization are also supported in I3S. 3D objects are your typical 3D graphics data set, typically containing also the mesh segmentation information, so that you know what building is what, as well as any other street furniture that you might have in the scene. So 3D objects typically are also related to integrated mesh, which is the second layer that you'll see next. But with 3D objects, mesh segmentation information is already included with the data. And the I3S format allows you to capture that information along with the geometry and be able to do, things like selection, identifying the object. The second layer that is closely related to, oops, I skipped it, I think, is integrated mesh. But this is your typical, let me play the video. Oh, the video is not playing, but that's okay. Integrated mesh is also very much related to 3D objects, but typically it's collected by drone and aerial imagery. Here you'd have skin of the earth type of data set where the trees and buildings and cars are all integrated into this single mesh. Traditionally, there's a challenge in having a good segmented mesh because oftentimes in GIS and cartography world, people would like to be able to segment the data and be able to work with a known quantity or known object. Integrated mesh data sets allow you to capture vast amounts of data, but typically do not come with additional information that would allow you to segment the mesh included in it. Point clouds, as I mentioned earlier, we released a detailed specification for it earlier in March. Your typical LiDAR data set, including immersive and aerial point clouds, are supported. Users generate billions and billions of point cloud. Typically in the GIS world, it's aerial point clouds that are of use for most of people, but also immersive point cloud dataset are also terrestrial point cloud dataset are also of interest for a lot of our users. Just a little bit about the premise here. I don't need to delve into it, but I think we try to check all these points, web-friendly, mobile, declarative, efficient, the premise that we had when we set out to do I3S. I3S data organization structure is a bounding volume hierarchy, very similar to 3D tiles, where a client application downloads a very thin skeletal node index document that allows it to traverse the data, and you then only request the actual content to render when you are ready or at the right scale. This information is indicated by a screen threshold error, where you evaluate what you got, the bounding volume information you got from the service or from the layer, evaluate it against the screen test that you can do, and then request the data if it is at the right level. If not, you descend down and get its children. It supports different bounding volume structure, minimum bounding sphere, as well as oriented bounding boxes are supported in I3S data structure. So, whatever is optimal for a particular type of data set could be employed to do the data selection. A little bit about the data organization of I3S here. Again, the skeletal node index document that is associated with it allows you to actually discover the data, what level of detail that it needs to be rendered, and then when you are ready for it, request this geometry data, attribute data, or texture data at the given scale. Obviously, data is built. There are many cookers that ESRI provides, or third-party developers also provide, that generates multi-LOD data structure and stores it into this bounding volume hierarchical data structure. Next slide, I think. SLPK has been an interesting format for I3S. This is a single large scene layer package that you can package your I3S data into a transportable format. People have been using it for actually transmitting the data, publishing it on the web resource, or just simply using it as a local rendering file. So most of the data providers that I mentioned earlier tend to output their content in this format in a scene layer package, which is just a file representation of an I3S. So really the essence of my talk today is about interoperability. Yes, interoperability is front and center. Geospatial users really want to use different content type, including I3S and 3D tiles in different type of application. CesiumJS is one, ArcGIS JavaScript application is another, and many other applications that they would like to use it. Our belief is that, the community standards, 3D tiles and I3S, that we all have been working in trying to get it adopted, are really the way to do it. In fact, we have had many users requesting to be able to use 3D tiles in ArcGIS application, and vice versa, I3S application, I3S content also in CesiumJS application. So this is really an open call for developers and content providers to start consuming I3S content in CesiumJS, and also vice versa. If you are an ESRI user, you're more than willing, you are more than welcome to write, custom layers that would allow you to consume 3D tile content. I'll showcase one collaboration effort that we did. I did show it last year as well. And we haven't managed to release the source, but we're planning to. This is a work that we've done with HFT Stuttgart, with Professor Volker Kors and his student, showcasing consumption of I3S data in CesiumJS. So if I exit here real quick, and so here's a custom application, CesiumJS, that oh, it's not showing. Let's see. Extend maybe. Yeah. All right. Now I can see it, right? Okay. So here's the CesiumJS application, and basically the idea is to be able to bring in some of the I3S content. Yesterday in CartoBoff, we were showing, there are different types of data set that are available in the ArcGIS Online and people's own cloud infrastructure. So the idea is, can I be able to grab one of these layers and be able to use it in CesiumJS? Obviously, what CesiumJS can consume and what is authored here in I3S 3D tiles is different format. So some sort of transcoding needs to happen to be able to consume it on the client side. So basically what we tried to do in that project was, well, okay, how about we go ahead and transcode the content, because they are very similar as far as the geometry content and texture content is concerned. How about we transcode it on the fly to P3DM and then be able to consume it in CesiumJS. So right now what I'm doing is I'm just connecting to the I3S layer, and as I do that, immediately you'll see content is being rendered and returned back to the client application. This jumping thing is doing because of, I think, the resolution of the screen, but it's fine. Now, you would see that if I switch to this rendering view, you'd see that there are multi-LODs being rendered in the screen right now. Sorry, actually, it's a little bit annoying, so let me change the resolution. 1920 by 1080. This should be good. You see it? All right. Okay. All right. It's not jumping now, right? Okay. Yeah. So multi-LOD data being requested from the server and being on the fly transcoded to P3DM here on the client side and being displayed and rendered in CesiumJS. So this is an opportunity here for third-party developers and consumers that they can. Now this is just touching top of the surface. It's not using in the ArcGIS application, as you'd see here. There's stylization and I think I need to refresh. There is a stylization, texture data. There's all that information that is not being really captured in here because as I said, like that was just a light. That was a collaboration project between HFT and ESRI. So there is a lot of opportunity to be able to get this content and rich set of content available in the I3S world into CesiumJS, and this is the open call for developers and data integrators to be able to start consuming it in different application. Well, that's what I had. Thank you very much. Any questions? Yes, in the back.
So you mentioned a number of different suppliers and parties who'd be interested in adopting the form. Have you had any interest from any of the safety critical fields, aerospace, any military partners or something?
So the question is, you've mentioned that there are many, I can bring that up, at least a few of the data providers that are, there are more. This is just a list that I had. Here it is. So the question is, I've mentioned that, there are data providers and industry adapting I3S, and have we had any interest from aerospace and facility management, maybe, kind of arena to use I3S? Yeah, I mean, our user base, the ESRI's user base, really spans that market segment as well. So personally, no, I haven't had any requests from that, but I would be surprised if there are not any desires to get it in. Typically, users requests come to us in a form like, well, we have already established workflows and would like to integrate this format into our existing application. So what can we do? One thing that we have done, I haven't put it here, is we created a good partnership with Autodesk in trying to consume BIM datasets in I3S. So that work is ongoing right now, and there's a lot of interest in that, trying to get geospatial data and BIM data integrated. So that's pretty much what I could say about that. Any more question? All right, thank you very much.
Very nice.
All right.
Cool. Awesome job, Tam. Yeah, so from the Cesium perspective, I mean, we're pretty hype on being able to ingest I3S and other ESRI contents for Cesium. We want to be as compatible as possible with as many data providers. So this will be a very good thing to get this rolling.
All right, cool, thanks.
And Dimitri, you're up. So Dimitri is joining us from Safe Software, and they're located in the greater Vancouver area, which is cool. So they're local. How many people have heard of FME? Okay, good number. So you guys know FME supports about 400 formats or so. So we see, again, compatibility with FME and working with these guys is a way to bring lots of different content into Cesium. So with that said, Dimitri, the floor is all yours.
Yeah, thank you, Patrick. So Safe Software is in the business of moving data between formats, between standards for 25 years. And 400 is it's a strange number for us, because probably if you count the list of formats that are available, you probably will count something like 370, 380, hard to tell. But if you take something like XML or JSON or even simple tabular data, well, anything can go there, and you can have hundreds and thousands and tens of thousands of formats covered by FME. So, and I would like to tell you a little bit how it all looks from my perspective, the development and moving towards this web-based visualization tools. For most of the, Safe history, it was mostly conversion, moving data between CAD and GIS. I knew this message by heart, so anyone would come to me at a conference, at an exhibition, I would tell this message, so how we move data and how it's bread and butter. Like 80% of our business is moving data from CAD to GIS and back and forth. So, and then of course, naturally, we grew into databases because people would like to store their data in spatial databases. Naturally, we added tabular data because, again, that's where most of the information is stored. And that's how FME grew into, expanded into different areas. Then we added support for rasters, of course, very naturally, and I played with rasters a lot, and then point clouds. But CAD to GIS always stayed on top of everything. So our rasters and point clouds maybe take 5 to 7% of our business. But suddenly I noticed last year at ESRI conference, actually, I didn't hear that question anymore. People don't ask anymore, how can I move my CAD data to GIS? It looks like this problem is mostly, well, I wouldn't say solved, but really well known, and a lot of people know how to do that, and maybe a lot of data is already brought over to GIS, to this world. But we get much more question about moving 3D data, like 3D data and BIM data to GIS and to maybe to Web 2 to show it, to share it. So sharing data is, became really, really important part of everyone's workflow, with open data, with public data, with government data being available. So that's what I noticed from my perspective. So, and probably maybe I should tell what I do at SAFE. Not to make you envy or something, but my role is to play, officially, to play with everything what is new and cool added to our product, and I can do whatever I want, seriously. So that's why when we added raster, I played with rasters, then later I played with point clouds. When we added Minecraft, I spent 1 year just playing Minecraft for a living. Seriously. And to me, it was a really great visualization tool, because I was taking real data, like the data, serious data, and was bringing it to Minecraft, and then, so, that's how you engage younger generation, wider audience to do whatever, well, share your information, your work with them. It was really great. So, usually we show this diagram like, we show CAD, we show GIS, we show databases going into FME and then going out. So, but this, because, well, that's what I noticed during the last World Tour, which we do once a year. The most popular theme of all the presentations that we did in all the cities, I attended the World Tour in 8 cities in North America. It was, interacting with web. Getting data from web, pushing data from web, analyzing data in web, visualizing data through browsers. And we prepared a demonstration. So actually Dale, who is here, asked me to do it just before showing something. He prepared this data set going from a CSV file and some boundaries, some real estate data, he made a demo going to KML. And he realized, like, just a few hours before the presentation, that he does not even have Google Earth on his machine. So, and he asked me, it was 10:15 in the evening, he asked, could you make that for me for tomorrow? Why don't we go to Cesium? So, and I make a very, that's the first time when I tried Cesium. I played with 3JS before that for a couple of years, but that was in April, first time when I tried Cesium. So I made this very simple presentation when we take KML file, just drop it in the browser and create a Cesium scene and open it in a browser. So it was really, really quick and very impressive. And we used that joke, oh, sorry, we forgot to install Google Earth during the whole world tour. And that's how we exposed, well, all the people we met during the world tour to Cesium to some degree. But from my perspective, so playing, if I would just play, that probably I wouldn't be, well, staying there for long. I have to share the results that I create. And how could I do that in the past? I would create a workspace. I will show you on the next slide how it looks like. I would create a workspace, publish it to web, and say, well, if you have FME, of course, you can download it, you can play with it, you can take this data and get the results. Well, but, or I could just make a few screenshots. But that's not what people really would like to have, right? So you cannot expect everyone to have FME. Then you cannot expect everyone to download it and play with it and be even interested in your problem. That's why I started, to really crave for something that would allow me to show my results easily, quickly, right away. And 3 years ago, I started playing with 3JS. I made lots of interesting examples with that. And in April, I started playing with Cesium, which is, of course, for geospatial world is much better match than 3JS. So, and this is this is our authoring environment where we create our transformations. I know a lot of you know FME, so this should look familiar. So we bring data in, then transform it in every possible way, and save it to wherever we need it to be. So, and those blue things called transformers, so that's, I basically play the transformers all day long. That's why I'm the coolest dad in my kids' school. And then Patrick asked me to try this new Cesium Ion thing and to load some CTGML data. So that's how I made an experiment with Cesium Ion. Downloaded some data from City of Montreal. They have the whole city in CTGML format. And once I sent it to Cesium Ion, that's what I got. You can see in the corner. So that's why it's not really a joke. There is no bad data. It's just data. Maybe whoever created it for themselves, it works well for them. So why bother with tagging it for a coordinate system or something else? So FME is really, helped me to solve this problem. Basically, I tagged this data set with a coordinate system which was just on the page, not in the data set, and then fixed some texture problems, and then after that you can see how nicely it looks there below. So, and then I played a little bit more with other data sets. So you probably heard that Microsoft released all the building footprints for the entire United States through OpenStreetMaps. And it's a really cool data set. And during the ESRI conference in July, we've got a lot of questions. What can we do? What can we do with that data set? And of course, it's something what I would try to do because, well, it's interesting. But when I checked the data set, I found that those footprints have no information whatsoever, nothing. So I decided to do something interesting with that. So I downloaded a single data set for the Washington State, and then I went to the website Natural Resources of Washington State and downloaded two raster data sets, DTM and DSM, digital terrain model and digital surface model. Combined those, it was like 40 gigabyte rasters and maybe 2.5 million buildings for the Washington State. So I combined those rasters together, clipped them with this building footprints. I got like 1 million rasters for 2 counties, small rasters, and extracted min and max value for each on each raster within each building. So that gives me the extrusion height. So, and that's how I extruded that and created the data set you can see on the top. I can switch to the real thing, probably like that. Yeah, here it is. The connection here is not that great as in my office, so, but you can see it's all here. 1.2 million buildings are here. They're just extrusions, of course, not real models. But for urban planning, for visualization on large scale in common sense of this word, or on a small scale in a cartographic sense, I think it's really good. So yesterday I published the blog how I did all this, so you can read it in our blog. So I'm returning back, and here this scene below it, I took an FBX 1 gigabyte FBX file, and actually SAFE is moving to this building in 2-3 months. That's why I found it really interesting to visualize it in Cesium. So that we can show our customers, look, we are excited, look at our new building, and we want you to be excited about that. And those 2 buildings are still not there, they don't exist yet. But of course, again, it's not enough to share the results. It would be really nice if you could not only share the results, but also the process of creating that. So, and when I created that first service KML to Cesium, it had fixed schema. You had to have certain attributes there, certain feature type names. And when I came back, I thought, well, I should make it really universal. It should be able to do anything to anything. So anything to 3D to Cesium. And of course, I can show you what I actually did. So basically, everything what you will see, it's just a workspace. The workspace, the one that I showed you, on one of the previous slides. I will go here. So a very simple form where we can pick any data in any format, as long as it's polygon data. So and here I have port coquitlam zip file, because it's a shape file. It consists of a few files, so that I made a zip file. It's a shape file, which I can just select here and say explore. And yeah. So, and this brings me a leaflet scene just basically to show where my data is and what attributes we have. I scan the file, so in shape file, and then I can say that I would like to, and don't look on those, I didn't try to make a cool looking page, but just the process itself. So one workspace created me this page, and the second workspace will create a Cesium scene for me. So these 3D tiles are here. So I probably didn't do something right. Let me go back. Yes, I had to say I will extrude by floors. Yeah, like that. Did I press it? I'll press it again. Oh, come on. Try it again, sorry. Fourth, 5. That's doing something. Yeah. Yeah, here it is. And I can use any format. For example, I can go back and select spatial light file or mapinfo file. Again, I have it in a zip format. And explore. So totally different set of attributes. Totally. So scan it, and then I can create some visualization there. So now I can create. So I can deliver very, very, very visually rich, very exciting presentations to everyone. But I also can make a service that everyone could use for processing their data. So, and that's what. And for me, it's really, really great tool of sharing, well, that joy that I have from my work. I really love what I do, and I'm really excited when I can show my results to everyone. So I think with that, I'm saying thank you, and if you have any questions, I'm glad to answer. Whatever I create, so yes, well, you have to have for me, but whatever I create is always available to everyone. Yes, yes. I publish it, or you can ask me, and I will share everything what I create. Sometimes if it's, well, data is not ours, then we cannot share the data, but the workspace is, yes, and data often, I try to always to find open data, free data, so that it's easy to share the results, yes. Yeah, the question was whether the workspaces that I create are available. Yes, everything what I create is available for everyone.
In fact, Dmitry, isn't there a blog yesterday one of these was on your blog yesterday?
Yeah, for example, yeah, we can go to blogsafe.com. Yeah, I published this yesterday. And at the beginning, you should see download the workspace, and you will get it. Of course, I don't give you download like 60 gigabytes of data. That you need to recreate that. But yes, yeah, it's all there.
In order to create a web service from FME, you need a server edition, or
how to create a web service from FME. So we have a desktop product and a server product. And when we create this workspace, which is, you saw the workspace, the picture of the workspace, or I can just show you that. Something like this. We can publish it to a server, and then it becomes a web service. You can create a form like you saw in my leaflet Cesium example. You can create a form, but whenever I press a button, behind that button is a workspace. Think like this. So it will run on a FME server and bring back the results.
FME Cloud lets you pay by the hour.
Yes, yeah, FME Cloud is an option where you don't have to host it on your machine. It just lives in the cloud. And whatever I do now, I publish everything to the cloud, and I can share all my results. So, and I create everything from these scenes to games and to all kinds of things, yes.
Any other questions? Great. Thanks a lot, Dimitri. All right, yeah, when I was watching the demo with all the different data that you can bring into Cesium through FME, I'm watching the Cesium ecosystem take like this giant leap forward. So super exciting. We have one more presenter today, Vangelis from Toyota Research. Has some cool Cesium stuff being used for autonomous driving, some of which I have seen, some of which I don't think I've seen yet. So I'm really excited to see that. In a prior life, Vangelis also worked for Google, where he led the Chrome GPU team. So we have Vangelis, Ken, and crew in part to thank for WebGL. So the Cesium team is very, very thankful for that work. It's all yours.
Let me plug this in for a sec. Cool. All right. Well, thank you all for being here, and thank you to the Cesium team for inviting me to give a presentation. My name is Vangelis Kokevis. I work for the Toyota Research Institute, and I lead the driving simulations team there. And in this presentation, I'm going to try to do a few live demos. So hopefully, the demo gods will be kind with us today, and so will the SIGGRAPH Wi-Fi. But I want to show you some of the web applications we're starting to build to aid our development processes at TRI. Before I get started, maybe really quick, TRI is a relatively young company. We're 2.5 years old. We are independent but wholly owned subsidiary of Toyota, and we have offices in the US in 3 locations, in the Bay Area, in Michigan, and in Boston. And they're kind of strategically placed. They're close to universities, and we do a lot of work with university groups from these places. So we kind of span the gap between production and research a little bit. There's more information on our website if you want to go check it out. But in a sort of a single sentence, if you could summarize what we're up to, is essentially TRI's goal is to improve the quality of human life through advances in artificial intelligence, automated driving, and robotics. And essentially what that means is that we want to both improve and extend the mobility of people, both inside their home and outside their home. The particular project that I'm working on is more related to autonomous cars, but we have a lot of, sort of about half of TRI is working on robotics projects, and simulation is very important there as well. Kind of different domain, but similar problems. And moving on maybe to the main topic of this presentation. Traditionally, a lot of the tools that we built at TRI were sort of these traditional Linux-based tools, so desktop OpenGL, Qt for UIs. And that works all right because Linux is the development environment that we have for everything else that we do. But there's a lot of improvements that we could make, and we're starting to see some pain points with sort of this pipeline of tools that we create. One of the obvious ones for us is as we create these desktop binaries. For people, it's kind of hard to distribute them around, especially because now we're somewhat of a distributed company. We have obligations with our parent company, Toyota in Japan. We have collaborations with universities. It's kind of hard to send sort of data around. So thinking about web applications and how easy it is to do deployment and updates and all that, it becomes sort of a light bulb kind of clicked. And we thought, well, maybe there's a better way to do this. The other big pain point for us is cross-platform compatibility. As we build Linux-based applications, we can run them the engineers can run them on their workstations, but a field operator that's out, testing a vehicle, they'll like to be able to visualize the results of the tests in a sort of more portable format. It may be a laptop, it may be a tablet. So obviously, the web is a big win for us there. As a development environment, I think for those of you who have done web development, the web is a great place to be at. There's tons of libraries, tons of help, and Cesium is one of them, really. It's very easy to create applications and put together components and end up with really nice results. But I think I would say the most important reason for us to move some of our front ends to the cloud is really that a lot of the data that we have lives in the cloud. So our cars drive around, they collect tons of data from their sensors, their LiDARs, cameras, and all that. That data gets uploaded to servers in the cloud. And now, in order for us to visualize them and sort of try things out and inspect the data, the only path we had previously is to download them, do these gigantic downloads of tens and hundreds of gigabytes onto a local PC and then sort of look around, and maybe that's not the log we were after, we would go find another one. So, so all this kind of led us to think that maybe there's a better way out there, and the web is probably, building web applications would probably be the right solution. So with that, I wanted to start with a simple example, and then I'll lead you through sort of a series of examples of the kind of stuff that we do on the web. Some of it is early work, some of it is work that has been done in the last couple of months, so you have to excuse the UI aspects of it, but it's also maybe a little bit of a demonstration on how quickly you can get stuff up and running on the web, prototype things, see what works, what doesn't work before you go and sort of prettify the UI and make it better. So one of the first things that we do before our car is able to drive out in the real world is that we take one of our vehicles with all its sensors, we drive it around the location that we want the autonomous car to drive at. We drive it around a few times, we collect the data, we upload all that data up to the cloud. There's some offline mapping process that we sort of collect all these point clouds and make sense out of them. We find interesting bits of them. And then eventually we create this high quality, high definition map. And that contains both the terrain surface. What you see there is a snapshot of one of these maps. The intensity in the colors indicates the LiDAR intensity that we get back, but it's also a very good way of sort of seeing what's in what the map contains. And these maps actually help the real vehicle localize itself, so when the car actually drives out in the real world, it can find exactly where it is with more accuracy than just pure GPS. And there's some other benefits. We get information about the lane structure and all that, so the car can drive safely around. So let me switch over to a demo now, and let's see how that's going to go. Okay, cool. So over time, we collect various locations. We started with sort of smaller places, and then eventually we start scanning more. What we have done here is essentially we've taken one of these LiDAR maps that we've created, and we use the Cesium Ion pipeline to import the data set into Cesium. And that actually allows us to create this map. Obviously, as I zoom out, this is the globe. This is a location in the Bay Area. But that's really useful for us because now we have the map in an online tool, and not only we can sort of poke around and see if there's places that our map is deficient, that we have to go and rescan, but also we can use measuring tools. So for example, if I want to find what the sort of dimensions of this lane are, I can sort of click quickly here and here. Again, I apologize for the UI, but it kind of shows you how, and this demo thing was put together by Peter in a matter of a couple of days. Peter, who's here in the audience, but it gives us information about the map. So if you look at this little window down here, it tells me the lat long coordinates of where I clicked. the distance between the points, and some other information that's useful for setting up scenarios. So let me go back to the presentation. And actually, maybe I'll continue with the live demo stream here. The next step, which is related to that, is as we want to do simulations, essentially that means putting cars in a virtual environment and being able to simulate their sensors and determine whether the autonomous car actually will do the right thing. In order to do that, we need to set up a scenario, exactly the kind of thing that we want to simulate. Originally, we used to do that through some sort of complicated Python scripts where you could go and punch in some lat-long coordinates, let the car drive, figure out if it does the right thing. Now we're kind of on our way of building more visual tools that we can do this work. So I'll show you an example here. I can create a car in Cesium. I'll add it to the scene. I'll create a simple trajectory. So let's say I have a car that's kind of driving down this lane here. I'll click a few waypoints. It drives there. Let me turn off some of these visuals here. Boom, boom. And if I drag the timeline in Cesium, you see that I just instantiated one of the cars that goes down the road. So let's say now that I want to study a case where there's another car that's coming across the intersection and is trying to hit me. So I'll create another car here. So this is Mr. Oblivious. I'll add him here, and then I create another trajectory. There's some interesting toolings that, given the velocity, the speed that the car is traveling, I can get. Let me make sure the timeline is reset. I can get the timeline to sort of automatically advance as I click this waypoint. So this guy is driving over here. He's waiting for me to come close to the intersection, and as I come in, I just boom. Oops, there it is. Let me bring the camera back out. I hope I'm not stuck in this view, but even if I am, and you'll see that sort of really quickly, we just created a scenario where there's a possible collision happening, and then we can export that scenario. We have some tools that we can export to a scenario format, and we can run it in our simulation tool. So this is the very beginning of an application that we're building with Cesium. Obviously, we need to do a lot more work on the UI and all that, but you sort of, hopefully you get sort of the sense of some of the things that we do here. Let me go back to the presentation I have one more demo that I'd like to show. I know that we may be running a little low in time. Okay, all right, cool. This is a project that we did actually in very close collaboration with the Cesium team. One of the big problems that we have is that as our vehicle fleet grows, we have a lot of cars that are driving around sort of all day long, and every time they drive around, they collect data from their sensors, and this data is in the sort of the hundreds of gigabytes. And so when the car comes back from a ride, it goes to the garage, we grab the hard drive from it, and we upload all this data to the cloud. So we have a cloud storage associated with it. So now all this data lives in the cloud. And the typical, and I mentioned that before, sort of our typical pipeline is that an engineer would sort of look through we have a web dashboard that we can search through logs. You can look at a log, you think, well, maybe there's something interesting going on there. You would download this to your PC. That would take, several minutes, lots of network bandwidth. And then we open a native tool that we visualize the log. And this works all right, but in a lot of situations, maybe not the whole log was not interesting, or it was totally the wrong log to look at. So what we wanted to experiment with is sort of an alternative solution where actually, since the data is out there already, we could have a viewer that allows us to automatically view it directly from where it is. And this is the Cesium log viewer that I'm going to demonstrate next. Boom, here. This guy here. Cool. So what you see here in this view, so now this is the playback of one of our logs. We have the circles around it are the LiDAR point clouds. So let me click play here. And what you see is the car is driving down one of the streets this is in Ann Arbor, Michigan. because we now see this in the context of the map, we have more ideas. So this is, a couple of city blocks around Michigan, but we have a better idea of exactly, where this is happening rather than just seeing the black and white map. What you see is not only the data that's collected from the vehicle, which are, these points, the point cloud, but there's also some of the data that we compute online. So these over here, these are detections that our system does while it's processing the point clouds. So for example, there's a clump of points here. Let me turn off the point so you can see it here. There's a clump of points. Hopefully you can recognize there's a car right next to us. And the online detector detects there's a car, and we draw this here as this sort of extruded polygon. And we can see that, and there's an interesting shadow effect that this has to the rest of the point cloud. But hopefully that gives you an idea of sort of the power of doing this online. And I wanted to mention also the reason why there's a little bit of a disconnect between where the car is and the point cloud is not a problem with Cesium or the app itself. It's just that signals come at different frame rates. So the vehicle position, we have a high frame rate update, whereas the point clouds come at a much lower frame rate. So the vehicle moves before we get the next point cloud. But let me let this play a little bit and sort of to give you an idea. Other stuff that we plot that's kind of interesting here, the green line, the green corridor that you see in front of the car. This is the trajectory that our planner decides that the car should follow. And that's very interesting for us to debug. And then on the right-hand side here, you see the steering wheel rotation. So this is all information that's stored in the log after we do a drive. And it's very interesting for us to inspect later on to see in case something went wrong and all that. So this is this demo. And I believe, yeah, I think that's it. Yep, please.
I guess this is probably a question for both you and Patrick, and maybe a general item is, you've got a lot of really cool data there as far as terrain information on roads and city infrastructure. And does any of that get shared for something like the Cesium World Terrain data set? Because you have high resolution terrain in these isolated areas. Useful for a lot of people, I think.
Yep.
If it was a public repository where, vehicle manufacturers who are gathering this data for research purposes could sort of share and have it modeled or pipelined into a global training model.
Cool. I'll repeat the question for those of you following. So the question was about whether all the data that we collect, for example, the high definition LiDAR maps, would actually be made available to others, for others to use through Cesium. The reality of it is that it's not currently. So I think every car company kind of develops its own scanning techniques, and they create their own maps. We're not quite ready yet to share them, and I don't know. I mean, it's interesting and useful data for others, but if you are in this space, you probably recreate that. That being said, there's companies that do exactly that, and I expect that Toyota and other manufacturers eventually, I don't think we're going to be in the business of scanning the entire world. So that data will become available by third parties, and we'll probably be licensing it like everybody else does. Yeah, but we're not in a position to share it yet.
Other questions?
Well, I have a question for Patrick. So there's a lot of widgets in the sandcastle UI. Are there plans to make some of those more extendable outside of the Cesium sandcastle for applications like?
So the question was in the Cesium Sandcastle, where all the code examples are, that there are some widget examples, and is there a plan to make them more broadly usable outside of the widgets? Yeah, so we have been doing some work with our widgets where we're trying to separate what I'll call the interaction from the presentation of the UI piece. So yes, and would love more of your feedback and maybe specific use cases for that. Other questions for Vangelis on autonomous driving? Cool. Well, awesome presentation. Thank you. Are there any other general Cesium questions? Okay, well, once again, all the slides will be posted on the Cesium blog and Twitter. Thank you, everyone, for coming. Thank you once again to all the presenters. And we'll be up here if anyone wants to hang out and talk more. Thank you. That was cool. I haven't seen the logs play that much data in it. Oh, yeah. So that was really cool. It ran really well. Was that data local?
No, it's
Really?
your server. Yeah.
Okay.
And it has pre-run. So I think
Yeah, that was really good. And then, yeah.